This is not a structure designed or built by human hands or modern engineering tools. It is created entirely by a small bird, using only instinct and materials from nature.
It has no hands, no tools, and no external guidance during the entire construction process.
Yet it manages to build a stable, durable structure capable of surviving wind and weather.
This remarkable builder is known as the weaver bird, a natural master of biological engineering.
It begins by selecting long strands of fresh grass, carefully choosing flexible and durable materials.
When these plant fibers are fresh, they are soft, bendable, and resistant to breaking under tension.
This flexibility allows the bird to twist and manipulate each strand without damaging the material.
As time passes, the grass fibers gradually begin to dry under sunlight and environmental exposure.
During this process, the fibers shrink slightly, tightening the overall structure of the woven nest.
This natural contraction creates a locking effect, strengthening the connections between each woven strand.
As a result, the structure becomes firm and stable, without any need for adhesives or bonding agents.
The construction process begins with a simple loop, carefully tied around a thin supporting branch.
This initial loop acts as a foundation, anchoring the entire structure securely to the branch.
From this point, the bird begins weaving fibers back and forth in a consistent, repetitive pattern.
All of this is done using only its beak, moving with speed, precision, and remarkable control.
Each strand is interwoven with others, forming a dense network of overlapping and connected fibers. The friction between these tightly packed strands helps maintain the structure without slipping apart.
This technique closely resembles human weaving methods used in basket making and textile production.
However, the bird performs this entire process instinctively, without learning or external instruction.
Gradually, the structure takes shape, forming a hanging chamber designed to hold and protect future offspring. The nest is positioned at the tip of a branch, reducing access for predators approaching from above. Gravity pulls downward on the structure, creating a constant force acting on the woven materials. At the same time, tension is distributed across the fibers, balancing the load throughout the nest. This distribution prevents localized stress, reducing the risk of tearing or structural failure.
Even when strong winds shake the branch, the flexible structure absorbs and redistributes the force.
This balance of forces demonstrates an efficient natural solution to structural stability and resilience.
The entrance of the nest is designed to face downward, forming a narrow and controlled access point.
This orientation makes it difficult for predators, such as snakes, to enter the structure.
It also helps prevent rainwater from flowing directly into the nest during storms. The aerodynamic shape reduces resistance, allowing wind to pass smoothly around the structure.
This is similar to defensive architectural strategies used in human-built structures for protection.
Many nests are built close together, forming a colony that increases collective safety and awareness.
Together, these structures create a complex and organized community within a single tree environment.
In this species, only the male is responsible for building and constructing the nest.
Once completed, a female bird arrives to carefully inspect the quality of the structure. She evaluates its strength, shape, and position before making a decision. If the nest does not meet her standards, She simply leaves and rejects the effort.
The male must then continue building or start over, investing more time and energy.
This process is known as sexual selection, driving the evolution of better construction behavior. The final structure represents an optimized design shaped by millions of years of natural selection.
It is built entirely through instinct, without any form of planning or conscious engineering.
There are no blueprints, no measurements, and no external guidance throughout the entire process. Yet the result rivals human engineering, revealing the extraordinary capabilities of nature's design systems.